Yes, hello students. Today we are going to discuss very important topic, that is differential calculus. Myself Jitendra Gurjar. Let us see what are the examples of differential calculus, what are the importance of differential calculus, what are the applications of differential calculus. In today's lecture, we see many things which are helpful for engineering. Yes, students, you can see that how differential calculus is important for engineering. So let us see one by one. Okay, so I think the screen is visible. Yes, students. Okay, so introduction to differential calculus. Here are some examples of derivatives illustrating the range of topics where derivatives are found. Mechanics, we can see, we saw that the derivative of position with respect to time is velocity. Very, very important, students, for mechanical students. Also, the derivative with respect to time is acceleration, right? So you can see here, students, and the derivative of momentum with respect to time is the force acting on an object. Simply as one. So how differential calculus is important for mechanics. We can also see for civil engineering, topography. Let suppose the function is given with respect to x, be the height of a road or altitude of a mountain as you move along a horizontal distance x. So we have to derivative, that is h of x naught, with respect to the distance is the gradient of the road or mountain. Similarly, we have very important application for population growth also. Suppose a population has a size p of t at a time t, the derivative p naught of t with respect to time is the population growth rate. The growth rate of human, animal, and cell population are important in demography, ecology, and biology, respectively. Yes, students, you can see very, very important application of differential calculus. One can see very easily. Also in economics, you can see, students, in microeconomics, the rate of change of the gross domestic product, that is GPD, what we say of a country, of an economic with respect to time is known as the economic growth rate. It is often used of economists and politicians as a measure of progress. So you can see differential calculus is very important in day-to-day life. Especially we go through the mechanical engineering. Suppose the total amount of heat produced by an engine is E of t at a time t. The derivative E naught of t of energy with respect to time is the power of engine, right, friends? So again, here we use differential calculus. We just move on our discussion with differential calculus. In day-to-day life, we are often interested in the extent to which a change is one quantity affects a change in another related quantity. So this is called rate of change. I think rate of change is nothing but differential calculus. What we use, that is differentiation, rate of change. Yes, students, we'll just go through the one of the example. If you know a motor car, you might be interested in how much a change in the amount of fuel used affects how far you have traveled. This is nothing but the rate of change is called here, especially, yes, students, rate of change is called fuel consumption of the car. So which is very, very important. Okay, differential calculus is about describing in a precise fashion the way in which related quantities change. Wherever there is change, related quantities change, we have to use differential calculus, which is very, very important, students. Okay, recognize and apply techniques to find a Taylor series for functions. So way back to differential calculus, we come to the mathematics. We recognize and apply techniques to find Taylor series for a function. So here we use the differential calculus, students. In mathematics, use Taylor series to solve differential equations. Also, we use Taylor series to evaluate non-elementary integrals. Yes, students, you can see very well. Taylor was a scientist. He said that by using differential calculus, one can very easily solve the differential equations, non-elementary integrals, Okay, so let us see how what Taylor has given the expansion. Taylor series expansion of f of x about the point x is equal to a, or a power of x minus a is given by. So we can see a function is given f of x which is equal to f of a plus x minus a, f dash of a plus x minus a the whole square 2 factorial, f double dash of a plus x minus a cube divided by 3 factorial, f triple dash of a, and so on. So by using this Taylor series, one can see we can expand this function. So let us go with a very important example. Obtain the Taylor's expansion of log x about x is equal to 1 up to the terms containing fourth degree, and hence obtain log of 1.1. Okay, let us solve this one. It's very important and very easy. You can easily solve this by using the Taylor's expansion. Okay, so let us solve one by one. So my dear students, you can see, yes, by using this expansion, that is formula, what we say, we are going to obtain the Taylor's expansion. So let us see by data. Yes, friends. So what they have given. So by data you can see here, right? F of x. I will take the function first. F of x is equal to log x. Is it clear? So one can see, and also given data is a is equal to 1. Therefore, I will just simplify one by one. So I will take this first value. First term I will take 1. I will solve f of a. So f of a is equal to what, students? It is f of 1. Am I right? So this equal to, just substitute in the above equation 1. So we can see this is log 1. Is it clear? So log 1, you know already. Please remember the formula I am writing on the RHS side. So log 1, please remember the very important formula, students. It is 0 means f of a is equal to, we have calculated, it is 0. We'll substitute in the Taylor series expansion, which is equation A. So I will take equation A, I will substitute one by one. Okay, next I will move to the, I want now f dash of a. So what I have to do? Yes, student. So I'll just take the value f of x is equal to, so I want to find the second value, f of x is equal to log x I will take. Is it clear? So what I will do, I have to differentiate because I want f dash. So therefore, I just go to the ordinary differentiation with respect to x. So one can see this is going to become f dash of x, which is equal to 1 upon x. But I want f dash of a. So means I will take only the a value and I will substitute here f dash of a is equal to 1 upon a. But please remember, I want a is equal to 1. The quantity they have already given, a is equal to 1. That implies f dash of 1 is equal to 1 upon 1, which is nothing but 1. So I will take this as equation 2. I will take this as equation 1. Is it clear? Similarly, I will move on to the next quantity. I will take this part as third one, third value. Okay, so 4 degree means, please remember, 4 degree means 4 times differentiation. Okay, I will write here. Fourth degree they have given here, students, means you are going to differentiate 4 times. Is it clear? You are going to differentiate 4 times. Please remember this, students. Okay. So let us move to the third value. I want to calculate f double dash. So what I will do, I will continue this differentiation. I will differentiate it once again, the above equation with respect to x. Is it clear? So it is going to become f double dash of x. So one can see f double dash of x, or differentiation will become minus 1 upon x square. Yes, students, you may see that how we have used this. Yes, first what I will do, I will take, you should remember the formula. I will write on the RHS side, that is x raised to n x raised to n minus 1. So one can see n is minus 1. So we can see here this value, I can rewrite this as f dash of x is equal to x raised to minus 1. Is it clear? So you can see x raised to minus 1 is there. So what I will do? N is equal to minus 1. So I will just substitute n is equal to minus 1. Though you can see minus 1 x raised to minus 1, or this is minus x raised to minus 2, or it is minus 1 upon x square. I have written same thing minus 1 upon x square as it is. So means to write this you have to use this formula. Yes students, please remember this formula, and you are going to substitute n is equal to minus 1. Am I right? Substitute the values in this equation. Therefore one can see easily, that is it is minus 1 upon x square. So but please remember what I want here students. Look at the expansion, it is f double dash of a. So therefore I'll just substitute the value f double dash of a. So one can easily see when f double dash of x is given, it is minus 1 upon x square is given, but here you can see f double dash of a is given means it is minus 1 upon a square. Am I right? So means, but I know the value of a. A is equal to 1. Am I right? A is equal to 1. It is already given. Therefore, f double dash of 1 is equal to minus 1 upon 1, which is equal to minus 1. I'll keep this equation 3. So I'm going to continue this. Yes, friends. I want again the next value. That is, again, I am going to differentiate this ordinary with respect to x. So we can see this is equal to f triple dash of ax, which is equal to, yes students, it is 2 upon x cube. Now you may ask, sir, how I got this value? Yes, again use the same formula. Okay, so I can rewrite this equation as like this. Okay, I will take this equation f double dash of x can be written as minus x raised to minus 2. Okay, it is in the denominator. If I bring it in the numerator, you can see x raised to minus 2 it will become. Therefore, I will use this formula once again. Therefore, you can see differentiation of minus x raised to minus 2 will be become, so n is equal to here minus 2 is there. I will keep minus outside, right? Again, this is minus 2, that is n, x raised to minus 2 minus 1. So one can easily see this is equal to minus into minus will become plus 2. Yes. So this is 2 into x raised to minus 2 minus 1 will become minus 3. So minus 3 means it will come to the denominator. So it is 2 divided by x cube, students. It is clear. Now we have triple dash of x is equal to plus 2 upon x cube. But then you remember that I have to substitute here. I want f triple dash of a, means I have to substitute x is equal to a. Okay, so let it be, which is equal to 2 divided by a cube. Am I right? So this is 2 divided by a cube, which that implies, but I know the value of a, which is 1. So this is 2 divided by 1 cube is 1, or the answer will become 2 divided by 1, which is 2. Is it clear, students? Okay. So, but remember, I want to find the fourth degree, means f raised to 4. So, fifth step will be again differentiating with respect to x run. So, please remember this. I'm going to again differentiate. This is fourth time I'm going to differentiate this. So, again, you can rewrite the same equation like this. F triple dash of t, this is equal to 2 x raised to minus 3. Can I write it like this, students? Yes, because this is in the denominator. If I bring it in the numerator, it is going to become minus 3. So can you find out the differentiation of this very easily? Yes, it is now minus 6 upon x raised to 4. Okay, you immediately will strike that how you are going to get this answer very well. Okay, now I know you have triple dash of x is 2 x raised to minus cube. So what I'm going to do, differentiate this once again. 2 x raised to minus 3 I'm going to differentiate. 2 is constant, I will write 2 outside. Differentiation of x raised to minus 3, you can see n is equal to minus 3 is there, so I will take minus 3 into x raised to minus 3 minus 1. Okay, further when you simplify, you can see here students. So this is equal to 2 into minus 3 is minus 6. See, very, very important step. 2 into minus raised minus 6, x raised to minus 3 minus 1. Again, very important step. Minus 3 minus 1 is minus 4. So minus 4 is there. I can bring it in the denominator. Therefore, it will become plus. So minus 6 divided by x raised to 4. Have I got the same answer, students? Yes, you can see here minus 6 divided by x raised to 4 is the correct answer. Therefore, but I want here f raised to what the derivative a I want to substitute. Therefore, one can easily write x is equal to a. So therefore, this is a raised to 4. That implies f raised to 4 1. Please remember, I know I want to find the value as a is equal to 1. Therefore, this is equal to minus 6 divided by 1 raised to 4. Okay, so it is minus 6. So this is fifth point. So I have calculated the fourth degree. Fourth degree is nothing but fourth degree is nothing but differentiating the function with respect to x 4 times. Please remember this. Note down this. Very, very important, students. Please note down. They may ask 3 degrees, 4 degrees, 5 degrees, 6 degree, 10 degree. You are going to simplify in this fashion. Okay, let it be. Now I'm going to simplify this value in our Taylor's series. I'm going to substitute all these values in Taylor series expansion. You can see, one can see here, students, that implies our function is log x, which is equal to the first value you can see here, equation 1 is 0. Okay, so one by one you can just substitute the values. This is 0 plus, please remember here given value a is equal to 1 is there, therefore I'll substitute x minus 1. 1 dash of 1 is 1 plus x minus 1 square upon 2 factorial, this is minus 1 plus x minus 1 cube upon 3 factorial. What I am doing here, students, I am just substituting the values which are already calculated in equation 1, 2, 3, 4 and 5. Just have substituted the values and therefore we get the Taylor series expansion. Students, see, if you have any doubt, please ask me. Okay, but this is not the answer. Please remember, just I have calculated log x, but I have to find with log x, I have to find obtain log 1.1. I will find log 1.1. Okay, so now I will substitute the value log 1.1, students. Now I can see this is equal to, substitute the values please. So this is going to become, yes, 1.1 minus 1, x is equal to 1.1. So this is plus 1.1 minus 1 square upon 2 factorial into minus 1 plus 1.1 minus 1 cube upon 3 factorial into 2 plus 1.1 minus 1 raised to 4 upon 4 factorial into minus 6 and so on. So you can see this is equal to, one can calculate in the calculator easily, can see it is 0.0953. Please use the calculator, students. If you don't know to use the calculator, go back to the videos and find out how to find in the calculator. Yes, this is our answer. Okay, students, one can see we have calculated this answer. So next example, immediately we will go with the next example, students. Obtain, yes, obtain the Taylor's expansion of log cos x. So very, very important, students. So they have also mentioned the point the point x is equal to pi by 3. Okay, students, let us simplify this. No problem. So you know already the formula. Please remember the formula and practice. First, you take the function f of x, which is equal to log cos x. Is it clear? Now You can take a is equal to, can you tell me what is a? Yes, they have already mentioned it is pi by 3. Okay, now see, again, please remember any degree they have not asked. Am I clear? So if degree is not asked, minimum you have to do 3 times differentiation. Okay, non-stop I will going to differentiate this one by one, students. Okay, so first I will take, I know f of x I have to calculate for f of a now. F of a is equal to, you can see, log of cos a. But please remember that f of a have calculated, but I want now a is equal to pi by 3. So means it is log of cos pi by 3. So just see, calculate directly in your calculator, you can see you are going to get the answer minus 0.3010. Is it clear? So I will take the equation 1. Okay, next go for differentiate. So what I am going to take here now? Take f of x is equal to log of cos x and then differentiate. So differentiate with respect to ordinary differentiation, students. This is x. So please remember the formula. I will write the formula on right hand side. So this is differentiate with respect to x, that is log u. Other function is there, that is cos x is there. Yeah, I'm going to use this. So this is equal to 1 upon u into du by dx. Is it clear, students? So now I will simplify this. So I will get this as f dash of x. So f dash of x, you can see this is 1 upon cos x into derivative of cos x. Okay, so what is differentiation of cos x? Yes, it is minus sine x. So this is minus sine x. So one can see minus sine x upon cos x. Can you tell me, students, what is sine x upon cos x? Yes, very well, it is tan x. So therefore this is minus tan x you are going to get. Okay, but I want to find f dash of a. I know the value of a, that is f dash of pi upon 3, which is equal to, yes, friends, it is minus tan pi by 3. Use the table, students. You can see what is tan pi by 3. Yes, otherwise you can calculate in the calculator directly. You are going to get minus 1.7320. So I will keep this equation number 2. Okay, next I will go for again f triple dash, students. Take again the function, take the value f of x is equal to log of cos x you take, then differentiate this with respect to x, sorry, take f dash of x, because I want to find f double dash of x, therefore I'm going to take f dash of x. So please remember what is f dash of x. F dash of x is equal to, it is minus tan x. Is it clear? So what will be f double dash of x? So one can see differentiation of tan x is sec square x. So that implies, but I want f double dash of a. But I know what is a given. It is pi by 3, which is equal to minus sec square pi by 3. So we can just calculate, put it in the calculator and tell me the answer, students. Yes, very well. It is minus 4. Yes, very good. So again, differentiate this with respect to x. You can see easily f triple dash of x is equal to, yes, students, please use the chain rule and tell me what is the answer. It is minus 2 sec square x into sec x tan x. Is it clear? So how I have calculated this answer? Yes, you can see here differentiating with respect to, that is, u raised to n divided by dx. So you can see this in the right hand side. I am writing the formula, students, here. So this is n u raised to n minus 1 into du by dx. This is in general. Okay, this is in general formula we have. So here you can see I'm going to take differentiation of sec square x. Okay, so n is equal to 1 and u is equal to sec x we have. So therefore this is equal to 2 sec x raised to 2 minus 1 into derivative of sec x divided by dx. So one can easily simplify this. This is equal to 2 sec x raised to 2 minus 1. Okay, then differentiation of sec x. Yes, friends, can you tell me what is differentiation of sec x? Yes, very good. Tan x. So again, further if we simplify, it is going to become 2 sec square x into tan x. Is it clear? So that, like that, I have simplified this. Here you can see it is minus is there. Therefore, this is equal to, please simplify this, friends. It is minus 2 times sec square x into tan x. But I want f triple dash of a, which is equal to minus, you can see I want f triple dash of pi by 3 because I know the value of 3. So therefore this is equal to minus 2 sec square pi by 3 into tan pi by 3. Using the calculator or by using the table chart, you can easily find the answer, that is minus 4 square root 3. So I'm going to keep this equation number 3. So substitute all these values in the Taylor series, students. One can see this will become log of cos x is equal to minus 0.3010 plus x minus pi by 3, as a is equal to pi by 3. They have already given in the question, you can check, students. So therefore this is into minus 1.7320, continue this, plus x minus pi by 3 into minus 4 plus x minus pi by 3 square divided by 3 factorial, this is 2 factorial, into minus 4 into root 3 and so on. So we can further simplify this. Therefore our last answer is log of cos x is equal to minus 0.3010. I will keep it as it is, minus 1.7320. You can write it down. This is x minus pi by 3, and this is minus, you can see this 2 factorial is there. 2 factorial is 2, so 2 ones are 2 twos are, one can easily simplify this. Minus I have taken outside, so this is minus 2 x minus pi by 3 square. Yes, friends. Then this is again 3 factorial. You can simplify this. So this will become again minus 2 root 3 upon 3. So 3 factorial is 3 into 2 into 1. So 1, 2 will get cancelled. 2 1 are 2, 2s are. And this will be x minus pi by 3 cube. Is it clear, students? So substitute like this plus so on. Is it clear, students? One can easily simplify this very well. Same way you can also do the next example. I will take taking f of x. Third example, you can note down f of x is equal to cot inverse x, students. So you can please try yourself. So I will just give you the hint to simplify this example. Yes, first time we will calculate f dash of x. which is equal to minus 1 plus x square raised to minus 1. Then I will substitute f double dash of x, differentiate this function. I will get this as 2x, 1 plus x square raised to minus 2, right? You can also go further, but this much is enough. But I want to calculate here in the power of x minus 1. So given, what is given here? Given x minus a, which is equal to x minus 1, that implies a is equal to 1. Indirectly they have given a is equal to 1, therefore this will become f dash of 1 is equal to, you can simplify this ones, minus 1 upon 2 you will get, that implies f double dash of 1, you can see this is also 1 upon 2, so you can substitute it in the Taylor series. This is just hint I am giving. Yes friends, please try yourself. Okay, this is going to become cot inverse x is equal to pi by 4. Directly one can see here students, directly substitute the values by taking a is equal to 1. So we can see, I will write it here, f of 1 or cot inverse 1. You can check this is pi by 4. So I am just substituting the values plus x minus pi by 4 minus 1 upon 2 plus x minus pi by 4 upon 2 factorial square 1 upon 2 plus so on. So this is our answer. Please, I have given directly the answers, right? So one, second equation substituted in this fashion, so one can easily calculate this values and you can get the answer students. Is it clear? Please try the example students. Yes, any doubts please ask me. Yes students, thank you.